This video is sponsored by Newer Engineering, where innovative engineering meets tailored solutions for your unique business needs. Click the link in the description to learn more.
Greetings everyone, welcome back to a brand new podcast video. My name is Ismail Arab.
I'm Rayan Sayed.
My name is Amin Chogle.
And my name is Amar Salman. Today we'll be starting off with a few main things. First, we're going to talk about programming and its applications in FTC. Second, we're going to talk about FTC highlights, our returning segment. So today we have our resident expert for programming, Amin Chogle. If you want, you can talk about a little bit more about yourself.
Hi, my name is Amin Chogle. I am a senior at Plano Senior High. I'm in the IB program, and I did FTC Robotics, and I was during my sophomore and junior year, and I was programming lead both years.
Very interesting. I've worked closely with Amin, and our whole team is very fond of him. He does really great work. So I think we should just get started with the main question about yourself. Why did you kind of get into programming? Was this something that you started when you were a sophomore, or was it something that has been growing for a long time?
I've been doing programming personally for a long time. Ever since I was in elementary school, I've been doing like small projects. When I was small, my dad brought me an Arduino, so I started doing small programming things with that. And later on, I started going into big stuff. After freshman year, I wanted to do more extracurriculars, and I saw an ad for this team, so I started to join. When I saw the possible sub teams, I wanted to join programming because my dad's in programming, and I wanted more experience in that, and I found it interesting overall. So I thought it would be a good idea, and that's how I got into FTC.
So participating in the FTC competition, how would you say your programming skills kind of developed?
I would say when I started the team, I did not know anything about Java. That's my personal highlight. After 2 years of being in this team, I know a lot. So that's my personal growth from being in this team. I would say at the beginning we watched videos, we looked at online code, and I got to find the pattern, the syntax for the FTC specific Java coding, and slowly a lot of testing, a lot of running, a lot of finding my errors about what's happening with the code, and that's how I got to develop my knowledge both this year and during sophomore year. During junior year, I think I started experimenting with different topics like odometry and image recognition. I started experimenting more with that stuff, and that's how I learned all the new concepts.
I know I say this I think I've said this in every single podcast till now, but would you say that for someone who's interested in programming, wants to compete in the FTC competition but has never had any programming experience, do you think having prior programming experience is required to participate in this competition?
Definitely not. And I'm a good example for that, because when I started, I did not know anything about Java, and the good thing about this program is you can slowly develop your programming skills from the beginning, and there's smaller experiments you can do, how to make the robot move forward. You can build up your knowledge as you go on. You don't need specific programming experience. Maybe some is good to have, but it's not necessary to join the team, in my opinion.
Very interesting. I joined my junior year, so I actually got that experience with you. So you're a little more experienced with programming. What's one thing that you'd say that about FTC in general, so it doesn't have to relate to programming, was a big surprise when you first joined the program?
When I first joined the program, I was surprised about the whole marketing aspect. I didn't know we would have to find sponsors and have to market and do outreaches. That was a new concept for me, and a lot of times for outreaches I had to represent programming and talk to others about programming. This was a good thing because I developed my speaking skills. I was able to talk more freely once I got to do outreaches, and it felt nice to have a good impact on other communities as well and talking about programming. So that was something I didn't know before that I'd have to do, but it turned out to be a good thing later on.
And speaking of those outreaches, how did you, because sometimes these outreaches kind of cater to underprivileged areas that don't have as good of a grasp on English as we do. So how did you present your programming kind of lingo per se to them?
I tried to use certain buzzwords like robotics and AI to try to get them interested. I wouldn't talk about specific stuff like odometry, teleop, and autonomous, roadrunner. Those are really specific concepts which would confuse them and maybe discourage them to join. I tried to use buzzwords which they would find interesting and exciting, and that would cause them to join to robotics.
Yeah, I remember using that because I think we had that one specific outreach. I think it was during this week of it was the expo, I think.
Yeah.
Where the week of outreaches that we were just having with different teams from around the world that some spoke English, some didn't. And I think you were I was really surprised by the way you were conveying the idea of programming to them, because I was wow, like they're not as privileged as us to understand English the way we do, but they're still like, they seem super interested, and they actually follow up questions as well. It was really surreal to watch. That was very interesting.
I mean, like just straight up, like before coming to this competition, when I had to pick a sub team, I didn't pick programming because I thought that if I did programming, I would just have to sit there in front of my computer like this all day. So how would you describe programming, like physically?
Programming is a lot more than just sitting on your computer, especially for robotics, because in robotics generally, we have to be with the robot all the time. Like we have to test different components, the movement, move the robot back and forth. When doing autonomous, it's a big part of doing programming. It's not always sitting on your computer. Sometimes when you're designing code, then you're sitting, but most of the time, it's a lot of physical moving that you have to do when you're programming the robot.
Makes sense. I mean, like, you have to do like the repetitive testing
Yes.
and stuff.
Yes.
Yeah.
Trial and error, trial and error, trial and error. That's my motto.
Yeah, definitely. I think I can specifically think about a time that we've actually had done this. I think like the night before our was it meet? What? I think it was our first meet.
I think it was our first meet.
It was our first meet last year.
I remember this.
I remember, yeah, we were all in the lab, we were like working on the final fine-tuning of the programming, and it was tragic, but it was honestly, it was a great experience. Like,
No,
it was fun.
but then on the last second it worked, and it transferred like almost like 10 or 15 codes in the end, bro, and we were all so happy and cheering. That was really fun.
I love programming, to be honest.
You doing?
Bismillah,
Begin.
bismillah, bismillah.
Begin.
Bismillah, bismillah.
Woo! Dude!
Right, then you ready.
Go.
Done.
Oh my god!
We got them all.
We got him all!
Wait, what?
Okay, here's the thing. It can be so frustrating when the code doesn't build. But the only reason that I love programming is when it works. The satisfaction.
The satisfaction.
Is the only reason
The satisfaction
that
is-
gets me to do the program.
Second to none. It's
As soon as you get the satisfaction, all that struggle just doesn't matter.
Exactly, yeah.
yeah, and then the entire team also like jumps with joy.
Exactly.
We're so happy. Oh my god, you're bringing back good memories. It was so much fun last year. Going back to specific applications of programming, how do you think FTC programming has prepared you for doing programming in more of a real world scenario for a job?
In a real world scenario, I think FTC programming has taught me that sometimes when you think it's going to work, it doesn't always work. Like, you yearn to be ready to get errors. Like, I would think that code's like perfectly built, and I'll forget a semicolon and throw all error on the code. So I know that I need to be ready for the code to throw errors even when it looks perfect, and I need to be ready to troubleshoot my code and debug it whenever it's needed. I think that's what FTC programming is really talking to programming in the real world.
Here, I think there's a lot of people that maybe that are watching that are considering FTC robotics or they're already in, but they don't know how to progress further, maybe in the programming sub-team. So, what would you say once you have the basic understanding of what FTC requires for programming? How do you think they could take it further?
Take it further, I would say YouTube videos. Like there's a lot of helpful videos on YouTube that can teach you basic concepts such as April tags or image recognition or odometry, and you can just like look at those videos and try to progress. Maybe try a few things in your lab. Not even like take it into competition, but maybe just test it out, see if it works, and then possibly further into the competition. But I think that's the best way to learn. Just to look at the videos, try it out, and see how it works.
Like, I know the FTC Discord is really active.
Yeah.
And they're always like up to date. If you have any questions, like I would definitely recommend like checking out the FTC Discord. They have a lot of good resources. So
what are the biggest challenges you faced while programming in FTC?
I would say the biggest challenge I faced was that programming is at the end of the engineering process, so sometimes the builders can take a longer time than I thought they would, and I would have to spend late nights trying to program the robot before the competition, and I think that was the biggest challenge, because I'm in the IB program, so time management with programming for robotics and also all the IB stuff that I have to do, it's a little bit hard to manage in my opinion.
well, that's a big challenge that you faced. But like more of a technical programming kind of challenge. What would that look like?
I would say that sometimes I would either Android Studio or the control would just throw random errors at me, and it was really frustrating because like the code's all good, it's gonna run if it pushes, but sometimes it's gonna throw an error. Android Studio is like there's this Java memory error that always like throw like at like random times, and it would be really frustrating. Like I just want to get the code to run so I can see if it works, and then keep throwing errors. So I would say that was a little bit of a technical challenge I had to face.
I mean, I was a driver last year, right? You were definitely working really close with us, right? It was
Yeah.
small things we asked you to push all the time, but I know like the driver hub too would just come like
Yeah.
disconnect randomly, like when it has like 90% battery, it just randomly disconnects. So, like
It's absolutely the worst. It's some of the
I feel like if I were a programmer, I think I would just lose my patience and run out of it.
I did so many times, bro. Like, it was actually.
programming is not for everybody. I think everybody can learn programming. I think they can do well in it. But sometimes it's just like
Patience.
It's patience kind of thing,
Patience
right?
is so important.
Well, anyways, thank you so much, Amin, for giving us your insight on programming and the FTC competition. And now we're going to be moving on to our returning segment. We're going to be doing the FTC highlights, so we're going to be reacting to a bunch of videos. So the first video we have is by its first updates, Team 7974, Great Scott. They have a robot overview, and we're going to be reacting to that.
I think it's their robot in 30 hours. But real quick, let's just introduce the people we have next to us. Let's just go and tell us your name.
Hi, I'm Yahya. I'm part of Expedition 21354.
And
I'm also Yahya. I'm a different Yahya though. We're not the same. Don't worry. I'm Yahya with Chief. I am part of the marketing sub team, and yeah.
yeah, so I think we're just gonna get into it. Yeah, this is their robot in 30 hours. And I haven't watched, I don't think none of us have watched the video. With the thumbnail, I'll put it on the screen for you guys. It looks absolutely crazy. So here, let's get started. Ready? 3, 2, 1.
One of the few floor intakes that we've seen too. Tell us more about your team and your robot.
Yeah, so we've made a lot of progress since our day one update video. As you can see, our active intake has updated quite a lot. We fully polished our linkage, and I believe we can actuate it now. It's a little bit jittery, but yeah, we can bring it up fully, and that gets us within the full 18 by 18.
This video on fun is made possible by viewers like you and also the following. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in FIRST scholarship. Scholarship applications will open in September. Get ready to go pro and get more information at kettering.edu/first.
We are 14 inches high, and you might actually be wondering how we do that with such a huge linear extension here. And the answer actually lies within a worm gear that we use to actuate these. You hold this real quick? Yeah. So our linear...
That is pretty cool.
Did we have a worm gear last year? Guys,
We had a worm here in Team 3, I believe.
Huh?
The third team adventure.
Yeah, I remember one of our 3 robots had a worm gear.
Yeah.
I remember.
It was a very good robot. I'm pretty sure because I remember a team was asking for it. Anyway, it was on a robot.
How did that work with y'all? Like I don't know why, but I feel like they had lots of trouble with the worm gear.
I'm in marketing, man. I don't know.
Okay, fair enough. That's my question for Coach Aldo. But as he's not here right now, I just want to talk about, that's a spin take, right?
Yeah, it's kind of like a spin tape.
It kind of looks like a hybrid of them. Like I'm not
Those
sure.
are gecko wheels. So
Okay.
it does function as a spin tape, but you know how we're used to like those flaps?
Mhm.
You know, like we use silicone tubing. They're using gecko wheels, which are also really good for this competition.
Do you think that they're more efficient with getting the obviously or they're probably going to show us in a little bit, but do you think just before, like, do you think they're more efficient or?
To be honest, we were considering gecko wheels, but our spin tape design, which I can't disclose yet,
Okay.
our spin tape design did prove to be more efficient than the gecko wheels, just because with our specific design, we're able to pick off any height of this, any height on the
Yeah.
stack. So
Very interesting. And this is in 30 hours.
Honestly.
yeah, robot in 30. Okay, wait. Okay, rewind real quick. Robot in 30 hours. They have an entire drivetrain, an entire working spin tape. They have a linear slide mechanism. Is
Yeah, I
that-
think so.
Yeah.
This team is on another level.
And it's on a worm gear, so they can fit under the whatever rail. And they did this in 30 hours.
Absolutely insane. Okay.
We need to digest that because we are working on that robot right now.
And like
And
months since kickoff.
It's been a month since kickoff, and we're now starting but we're now starting with building our mechanisms on our base. When these teams are creating an entire robot in 30 hours.
Yeah, I'm not sure what region they're from, but I would definitely want to see the robot in person. Here, let's continue real quick.
Your slides actually fold completely down under the 14-inch height limit, which allows us to go completely down. Currently, our procedure includes driving completely down, and then intaking, driving out, and raising our slides again to score.
Can we see some of that happen?
Currently, we're still working on the actual outtake mechanism.
Is
So,
any of this, if you're not able to move it electronically, or you're going to move by hand, so you guys see those stages?
We can move it for the intake.
So this is our outtake mechanism. We just have to mount it on, and then it'll just rotate up. So it'll grab them, flip up, and then we can open the claw and drop them onto the backdrop.
That specific claw was really popular last year. The one that was powered by one servo.
Yeah.
So it's kind of cool to see that people are using well, I mean that claw is pretty universal. Like I've seen it applied in other competitions like Bex and stuff.
Yeah.
But that claw is really efficient because it utilizes one servo to control two different fingers.
Is there any problems with that? Like, could that cause some troubleshooting possibly?
So the only problems that I've ever had with that claw was that it sometimes would be really slow. I don't know. I mean, I think that was just because the specific servo we're using a Go Builder servo, but it was just really jank, not working. The other problem is it needs to print accurately. If the gears are offset by a millimeter, then it's not going to close in all the way. So you need to make sure that it prints correctly. That's what we ran into that issue a lot.
Yeah.
We didn't think it was a big deal, but it actually was.
I think it's interesting that, sure, I'll come back in a second. I think it's interesting that last year the cones were all vertically, right?
Yeah.
So you had to pick them up like this. But this year they're picking up the pixels like this. So then when they flip it on the board, they can just put it like that.
I've seen teams actually do both ways.
It's interesting. I think the video we watched last week, they used kind of how it was last. I think it was on our remote here. Kind of how it was last year. But then this team is kind of doing it a little bit different.
Yeah. Look, we actually have the same claw. Well, we only have one finger right now. So it was actually everything was good with this claw, but the issue was actually with this servo. It was it'll close really slowly and then really fast. It would start slow and then close fast. I don't know why that was. All of our Go Builder servos are really damaged, but that's the only issue we ran into with that claw. But it was really efficient.
Yeah, you were saying?
Yeah, also, I would say that the interesting thing I see about this claw is that a lot of teams that I see, I feel like they're doing, if this is a pixel, right? Their claw is going like that. But this team's going like that.
Yeah.
And you have to be much more accurate to do
exactly.
that. Driving has to be top notch. But I mean, if they got it done for 30 hours.
That is a part of their outtake, though. That is a part of their outtake.
Yeah.
So I think they're using, obviously they're using their spin take with Gecko wheels to intake it. I'm curious to see how they transfer it into that claw, though. Maybe there's a coin slot or something.
I think that they said they're not completely done with doing that. Here, let's continue and see what they have.
Yeah, so you can probably see that our intake's goal is mainly to get it into this back black area here, where we will actually have the claw seen here, pick it up, and then be used to deliver. Be used to deliver the object. Our main goal is that compared to just using a claw with all of the kind of trickiness that comes up with dealing a passive intake, using an active intake feeding into a claw will allow us to collect the pixels a lot faster.
I think a great point there. I think what they're saying makes a big difference, but also it's a little unrelated. But I think it's kind of fun that they're all wearing white lab coats on top of their regular clothing. I think that's pretty fun. Obviously, probably not necessary, but definitely kind of cool.
It's super funny.
Yeah, very, very fun. Also, what I noticed is they seem to be using a slide that we kind of used last year. And I wasn't expecting to see many of those like kind of like layered slides. I'm not sure what they're specifically called, but I wasn't expecting to see many of those this year, which kind of tells me that they're aiming to get a lot of pixels for it to like get pretty high.
Yeah.
Which is, I think it's interesting. Like, that's a good goal to have.
Yeah. I mean, last year we transitioned to SAR 230s. Whatever. Is it SAR 210? Sorry. We transitioned to SAR 210s because they were like extremely light, and the slides that they have on the robots are like, they're really heavy. And I think because this year, because we're shifting towards more of a smaller robot, it would be, I don't know how having those slides, I don't know exactly, are those Viper slides? I don't know, but Viper slides are really heavy, so for smaller robots, I don't know how that would affect the center of gravity. But
I think it's interesting. It looks like the robot is heavier on one side than the other. I don't know, because I don't see anything that could like counter the weight.
No, there are like.
Is there something?
Wait, no. Actually, you might be right.
I don't know. I think it's gonna be interesting seeing how they are gonna deal with that. Maybe the add counterweight.
the thing about having smaller bases, like smaller robot bases, is if you're gonna have an angled linear slide, which it looks like they have an angled linear slide, you're gonna need to definitely balance the weight, and that means you're gonna have to like you're gonna definitely have to add more weight to one side of your robot. And then all of that can just eventually just add too much of a strain to your motors, and that can eat up battery life. It's just a lot that goes into it.
Yeah.
But yeah.
Definitely very interesting. These are pretty fun. I like them.
How about your elevator stages? Can you just talk about what you plan on doing or what you are using for that?
Yeah, so what we're using them for is, so we actually have 4-stage Viper slides right now, which are from our last year's robot, which we really don't need 4, we only need 2, but it was a lot more work to make it 2, so we're just...
I think that's exactly what I was saying. Like they just took it from last year. I was like four Viper slides are pretty tall.
4 stages Viper size is like,
I think that's almost the tip
that
of
goes
the
higher than the
board.
Yeah,
Is it?
Yeah, it goes higher than the
that. Yeah, I was like, wow, but it makes sense. It's more work to remove too.
So if they recycled mechanisms from last year's robot, that probably explains how they got 30 hours of
Oh
robot
yeah,
time.
for sure. Having it like an optimized kind of system and working around that, at least for the first iteration, is definitely a good idea.
Yeah.
Very.
It's like, it's efficient.
Yeah, no, that's definitely like, honestly, that's the strat.
We've tried Viper slides in the past, but I actually want to see the Viper slide run, because like we've had working Viper slides, but because of the way we built our robot's base, like it was just, in the long run, it was just not the most optimal solution.
Definitely.
And they're really hard to work with. It looks like they're string too. You know how much trouble we have with strings?
Don't even get me started on string, dude. I'm not on the freaking team that had to do that, but you guys looked like you guys were having the worst day of your lives. Like,
with the Viper sides too, like they would snap almost every single trial, re-rigging the string, everything. Oh my god.
I remember I was like across the room, like working on something, and I just hear like, the string snapped, and then like 10 minutes later, I like come back in the room and like they're like, dude, it snapped again. And I was like, oh my god, it was great. It was
Things like that happen all the time.
I'm getting nightmares like looking at the Viper slides right now, bro.
Don't worry the string. We don't have the string. Anyway, here, let's continue. See how they do.
But we've actually added a hard stop that doesn't let it go past 2 stages, because 2 stages is all we'll ever need to get it up high enough.
And then anything from your drone launching mechanism you want to cover or talk about?
Yeah, so we worked very hard on that overnight, and this guy here has been working on it very hard this afternoon as well.
You want to talk about some of the composition of it, and then we'll show it off.
So pretty much we have a servo back here that we use as like kind of like a trigger to where once it's released, it'll fire the drone. And then we just have like a rubber band here, like most other teams, to shoot the plane or the drone.
Have you been able to launch it?
I think the biggest challenge for the airplane mechanism is consistently making sure it lands in zone 1.
Yeah.
I've seen really unique airplane designs that actually aids in that consistency, but you know, I've seen lots of mechanisms with this where there's like put it in between 2 like U channels or whatever, and it just flick by like or just get launched by a rubber band and stuff. So I'm actually curious to see how accurate it can.
Yeah, and also I feel I'm honestly surprised that they put everything in the first iteration. Like I'm not sure, but I would say that doing the airplane mechanism is slightly harder than a hanging mechanism, even though it looks easier. So like I feel like a lot of teams, they would focus on just the basics instead of, you know, biting more than you can chew. So I'm impressed on how they did everything at once almost.
I also want to point out like how complex this the season's game is, right? So much different components.
Yeah.
The airplane, hanging, scoring, it's all like a huge challenge, especially.
Yeah. First tech challenge. That's probably it's in the name. But also, as someone who's not involved in the building or the programming or CAD at all, I want to disagree with the point. I think hanging is harder than the airplane.
Yeah.
And I say that because I think it's just because you have to add in a separate mechanism. I don't think you could I don't think without like a lot of reinforcement you could use the same. If you're using a claw, then you can use the same claw, and maybe you could. But for this robot, they're not even using a claw. How are they gonna hang? That's a completely separate mechanism.
Yeah, that's true.
More weight.
That's true. It is a separate mechanism, but I would argue still that like the airplane mechanism is harder because it's not the mechanism is not just meant to just throw the airplane.
Yeah.
It's supposed to calculate. Okay, it needs to land in zone 1 if we want to get the most points.
Is that what the mechanism is gonna do, or is that how we're gonna build the airplane? Because I think the strategy is
I think
obviously
we need to make sure both aids and making sure it lands in zone 1. Like we still haven't decided whether we want to use like gecko wheels or if we want to use like a rubber band or whatever. But if whatever we use, we need to make sure that both the airplane and the mechanism are both optimized so we can only land in zone 1.
Yeah, we'll take it from our resident podcast expert on building stuff. I think I guess it makes sense.
And then I would say for hanging, you don't really need to have an entirely separate mechanism. Whatever claw you're using, as long as you're using a high torque motor, if you can just grab the rod and lift the robot up, it does the job. No, it doesn't need to elevate all the way. It just needs to make sure it's above.
But I don't know, because see, let's take it for like an example that we have in front of us. How do you think they're going to implement a claw for the hanging mechanism?
Well, actually, just looking at their design, I would say if they could, using their worm gear, they can just keep the slides vertical. Maybe just have like a little hook, extend the slides up, hook it over the rod, and then just retract the slides and somehow lift the entire robot up.
Yeah, obviously it's light enough.
Yeah, that is definitely going to require a light robot or really, 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 really high torque.
Yeah, which will wear out, definitely. But yeah, that's definitely, that makes sense actually, yeah. Anyway, you was continue.
Testing? We have not gotten the servo connected yet, so we have not been able to test it yet.
Before we get to the questions about your robot or anything else you want to cover on your robot?
I think that's everything on our robot.
All right, let's get to some questions from our audience here.
All right, add B.
I think that kind of hits on the fact what Yahya was talking about. Like, they kind of, per se, bit off a little bit more than they can chew. Like, they haven't finished the outtake. Like, this is a little bit less polished than the other robots in 30 hours or 40 hours that we've watched. Because they knew what they were going for in the time frame. They tried to do everything, I guess, except the hanging mechanism. But obviously, that's not to discredit them or anything. Like,
straight up in 30 hours that you guys were able to make a robot like this. It's absolutely crazy.
Like, it's an absolute like feat. Like, it's a marvel that you guys do that. Definitely very cool. We did not make a robot in 30 hours, so how much can we really say?
Yeah.
But yeah, no, very, very cool. But I just found something I wanted to play. Okay, guys. Now we're gonna move on to the second video for FTC highlights. This is Team 11047. Screw it. It's their robot in 1 day reveal. I think. See, Screw is a very interesting team. I think Ismail was telling me about it like earlier today. What were you saying about it?
They are amazing. They're just really their games are always high scoring. They always have a really good functioning robot, very efficient in everything. Like in the past competitions that I've seen them participate in. And I just love their name, to be honest. Screw it. It's just their name is just something else.
I've honestly never heard of this team, so I'm kind of excited to hear like branding. I'm kind of excited to see
because
what
like
the robot is like. No, branding.
No, I can't believe you do it like that. Wow. I'm kidding.
Like you're branding for them.
Today's podcast is sponsored. Anyway. Well, wait. So I think the expertise for them being an FRC team as well, because their channel name is Screw It, FTC and FRC.
Oh.
So their expertise in FRC team probably helps them out with that. What do you think so? Like, do you think that's a big part of it?
Wait, Screw It participants in FRC?
It's in their channel name.
Well, I think maybe Screw It is like a 1 in 2 because, you know, a lot of, like FTC teams, for example, us, we have FLL teams that we mentor.
Yeah.
I know FRC teams do the same thing.
So maybe that's something that they're doing.
Yeah.
But do you think that expertise could help them out?
Yeah, FRC is usually more rigorous because you have like less of a time frame than FTC and stuff. So yeah, I mean, but I think they have a really OG number. Like 11047 is like really a really OG number. So
Yeah.
they have many years of experience. So
Definitely. And I wonder what season it started. There's definitely some really old teams. Here, well, actually, you've really set the bar high. So I'm kind of excited what they're gonna do.
Oh,
Robot one day.
I know. Like, I'll be so sad if the robot isn't like.
You're very good standards, really high.
Yeah. If it's not good, actually, we're all blaming it on you.
Yeah.
That's your fault. Anyway, let's start.
This is exactly what I was talking about just a second ago, about how you can just have a hook on your linear slide.
See,
Isn't that crazy?
you know what? I want it to be like little. I want to be like poke fun and be like, oh, the robot. Like after we watch the video and it's like not that good. I want to be like, hey, Smile, you don't know what you're talking about. But they have the hanging. They have a pretty fast intake and outtake. Like if the robot seems to be going pretty fast. I don't know how light it is, but it's kind of zooming. Honestly, it's going really fast, really well. They're playing basketball behind this. They know that the robot is going to be perfectly fine.
Oh my god, everything
One
is
day,
so smooth.
one day, 24 hours, one day.
That's
Oh my
crazy.
God.
No,
Actually-
can we just like the smoothness in their like driving and their transfer? Well, there was no transfer there, but just the smoothness in general is just crazy, bro.
Very. See, now I'm excited to see what they're gonna do.
So Amar, actually, I want to show this to you real quick.
Yes.
You see how on their linear slides they have a hook?
Yes.
So you don't necessarily have to create an entirely new mechanism. Per
Yeah.
se. You can just kind of like add a little add-on to something that's already existing on your robot.
Yeah, I didn't consider that. That actually is so interesting.
This means high torque motors. So
Definitely. Yeah, let's continue.
sorry, I thought I just saw it like flip the.
No, I saw that too.
Oh, you saw the pixel flip?
I think it's backwards. Are they taking it off the board?
Are
No.
they? Wait, what?
No. It flipped. Yeah, I think it drove over.
Oh,
Oh,
okay.
okay.
Sorry.
I was like, they use the force now? Is this the next level? What?
I'm tripping.
That's good. You know, really quickly one thing. Their claw is angled. Their claw is like this, and then they pick it up and they kind of just swivel like that.
Yeah.
Which I think is
We're gonna see a
honestly-
bunch of robots that are like that. I know for a fact there are gonna be tons of robots that have that similar mechanism and stuff, but I'm just like surprised that they were able to make this in just one day, super smooth. Like Team Screw It 11047. You guys are actually insane for creating a robot this good in just one day.
It's been 1 minute and 11 seconds, and I'm already blown away with what you guys have done in one day. Absolutely crazy.
Yeah, it's wild.
And oh my god, that's so cool because their claw. This is definitely better than having like a claw like this and like kind of tilting it and picking it up.
Yeah.
This is definitely the way more efficient way to do it.
So I'm just curious to how they pick off. Oh.
What?
Though I think I know how they're gonna pick off stack. They can run the motors for the linear slides, let the claw elevate a little bit to from different levels. Yo, that's actually pretty crazy. I don't know how efficient that would be, but still, it's a working mechanism.
Also, I would like to say, I feel like a lot of the successful robots last season, they were the more simple robots. Like they just had, you know, you were saying this earlier, like they just had one servo, go up, put it. Like the robots that I feel like our teams built, they were good, but they were a little complex, and that did come with more problems. This robot, they have a simple, like, just pick it up, put it. You know, it's really cracked, like the way they do it.
At the end of the day, as long as you're like scoring like high, as long as you have a high scoring robot, that's all that matters. You know.
Well, see, you said simple, but I also think that a lot of thought went into the way it's moving.
For
Like,
sure.
like in one thing.
Like from the outside.
Super. No, even dude. I can imagine them at kickoff, like they see the field, they see the field, they start like jotting down, catting, absolutely crazy.
You know, it's like videos where it's just you kind of sketch it. I can just imagine them sketching it. The robots just.
They're like, oh, this is the design, final design, guys.
Yeah.
That was like perfect. That's very, very amazing. Right? It was amazing. That was a great video. Here, let's go into final thoughts. So, you guys, final thoughts on the video?
Final thoughts, like as I said before, you guys are crazy robot, 30 hours robot in a day, whatever, robot in 2 days. You guys are absolutely phenomenal creating robots. I'm just at a loss of words. It's crazy.
Yeah. Absolutely amazing work that you guys do. Like, very cool. And at the end, like they showed they showed their airplane mechanism, which is just them having like lifting up the entire thing and then launching it. Which
that's crazy.
So they did everything, right? They did hang, they did airplane, they did quick and fast delivery of the pixels. What else did they need to do? Like that was this is a good Meet One robot. This is a Meet One robot that they made in one day. In one day. This was 3 days ago.
Oh.
This video came out 3 days ago. It was a month ago. Imagine what they could do now.
Oh my god. And also, the airplane, I honestly, I don't know, I've never thought of this, but I feel like a lot of the teams are going to be launching it from down there, like the field is here, it's going to launch up and down.
Yeah.
They decided to go up then launch it down.
Yeah.
And okay, at the end, they had the bloopers, right?
Oh yeah.
And I can't tell whether when the airplane hit the end of the field, was that a blooper or are they doing that on purpose because they're just that smart?
Okay, wait, if they're doing that on purpose,
is it consistent? I don't think so.
if it is consistent, how are they making that consistent? Like, how are you able to aim? Maybe, I was thinking about a lot of crazy ideas for the airplane mechanism that I'm designing. I'm not gonna disclose it, obviously, but definitely making sure the airplane lands in zone 1, make sure it lands there consistently. That is a big challenge. Delivering an airplane is not a problem. Anyone can do that. Yeah. I'm trying to figure out a way for it to consistently land in zone 1. So that whole elevating and shooting it downward is actually makes shooting an airplane a lot more accurate.
See, it's interesting because I have a lot of airplane ideas, but it's all interesting because you have to make them work together. The mechanism has to be good but not too good.
Yeah.
The airplane has to be good but not too good. It's such a middle road. It's
exactly.
It must be just right.
Yeah, Goldilocks.
I was just thinking the same thing.
It's literally just the Goldilocks effect. It's gonna be I can't wait to see what people's gonna be 1, 2 in the tournament.
Yeah.
And the world's teams, how are you gonna efficiently and effectively do that?
Oh my god!
I'm so excited.
The thing I love about World's team is their robots are always so unique.
Oh yeah.
I want to see all this, especially for this competition with the amount of mechanisms you have to have. like score high in this competition, I know we're gonna see very unique robots.
Well, see, for us, that's not a problem because we're gonna go to Worlds. We'll be there. We will see the robots, the mechanisms, the airplane launching. We will do it. We will be there. So yeah, we'll comment on that later. Definitely. Like we're gonna have some fun.
And if any of you guys are also gonna be at Worlds, don't trust me. We'll see you there.
Yeah, we'll see you there. Well, trust us. Yeah. But yeah, that's very cool. I think honestly, final thoughts for both of these videos, impeccable. Great, crazy what you guys can do in a day, 30 hours. What can't you guys do? Like you guys definitely put some good work into what you guys did. I can definitely see that, right? Very. Anything you guys have to say?
No, that's pretty much it. Crazy job, guys. Congratulations on killing robots. I hope you guys like I know that if you guys are able to make this in one day, your final robots are gonna look crazy.
Ooh, yeah, that's gonna be great. See, look, this is why we're watching videos, so we know who we want alliance with. You know, see, that's important.
Yeah, we're gonna be the winning alliance captain on Worlds. We just need to see who.
Yeah, we're like those guys, we want those guys. Yeah, that's how it goes.
And also, in the beginning of this video, you asked whether being an FRC team would help them. I feel like these are FRC level robots. Yeah. I think yes.
Yeah.
I would honestly say so.
Look at the wire. I don't know if you guys are on the same frame. Look at the wire management. Like they have this like a good wire management so that it doesn't get tangled up and kind of mess up later. Like this, all these add up. Like it always makes a difference, right?
Yeah. Last year we had some issues with wire management.
Disconnection. Oh, don't even. Okay.
Please meet our sponsors. Thanks East Plano Islamic Center, SolidWorks, Cafe de Khan, Sarah's Amal Biz LLC for your precious and invaluable support and sponsorships and take us to the next level. Again, thank you very much.